Welcome back to the channel. Today we're tackling a common bottleneck, distribution. We are going to build MarketMind, an automation engine that turns your technical blog posts into high-engagement social content. We'll use Claude Code to scaffold the project rapidly so we can focus on the prompt engineering logic. We'll start by initializing a clean directory. I'm calling this MarketMind. We initialize the package.json with defaults. Standard procedure here. Now, the dependencies. We need OpenA for the intelligence and Puppeteer to scrape our source material. I'm also grabbing Dotenv to manage our API keys securely. Never hardcode your keys, even in tutorials. Since we're writing production-grade code, TypeScript is non-negotiable. We need the types for Puppeteer specifically, as the scraping DOM manipulation can get messy without type safety. Let's initialize the TypeScript configuration. We'll leave the defaults for now, but we might need to adjust the libcompiler option later depending on how Puppeteer behaves. I'm delegating the boilerplate to Claude. I need a scraper, but I don't want to spend 10 minutes writing selector logic. I'm asking for a robust function that handles the basic scraping workflow. Claude gave us a decent starting point. It's launching a headless browser, navigating to the URL, and waiting for the network to idle. That's crucial for single-page applications, SPAs. However, grabbing document.body inner text is a bit crude, but it's sufficient for our MVP. Here's where the magic happens. I'm explicitly asking Claude to force the output into a JSON structure. This is a common pattern in AI engineering. You don't want unstructured text. You want structured data you can programmatically handle. Let's review the code Claude generated. It sets up the OpenAI client and sends the prompt. Notice the system prompt, output JSON. This is a soft constraint. In production, we'd want to use OpenAI's JSON mode or function calling to guarantee validity, but let's see if this works as is. Now we need the entry point. We'll simply grab the URL from process.argv, pass it to the scraper, and pipe that into the generator. The logic looks sound. It's a simple linear flow. Input validation, scrape, generate, output. Let's create a dummy blog post file or just point it to a real URL to test. Moment of truth. I'm running this against a sample tech article. The scraping log appeared, so Puppeteer is working. Now we wait for the LLM latency. And it crashed. Look at that error. Syntax error, unexpected token. This is the classic struggle with LLMs. The issue is clear. The model didn't just return JSON. It was polite. It said, here is the JSON you requested, followed by the data. JSON.parse is strict and choked on that conversational filler. Let's ask Claude to make the code more resilient. Claude suggests enforcing JSON mode. This is a feature OpenAI released specifically to solve this problem. It forces the model to output valid JSON, removing the need for us to write complex regex parsers to clean the string. I'm applying the fix. We add response format, type JSON object. Note that when you do this, you must also mention the word JSON in the system prompt, or the API will actually throw an error. It's a quirk of the API design. Let's run it again. Scraping, generating, and boom, there we go. A perfectly structured JSON object with our LinkedIn post and Twitter thread ready to go. We have working code, but it's script kiddie code. To make this a real tool, we need to refactor. I'm asking Claude to wrap this in a content engine class. This allows us to inject dependencies later, like swapping OpenAI for Anthropic or Puppeteer for a lighter scraper, without breaking the app. Look at this cleaner structure. We are injecting the scraper and generator into the engine. This makes unit testing incredibly easy because we can mock the scraper and just test the logic flow. Finally, let's add some utility. Printing to the console isn't useful. We want to save these drafts to a markdown file so a human can review them before posting. Claude added a save to file method. It takes our structured JSON and formats it into a readable markdown document. It also sanitizes the file name using a regex to prevent file system errors. Final test run. It scrapes, generates, and saves. We now have a tangible artifact on our disk. Opening the file, and it looks perfect. This is a tool you could actually use in your daily workflow. So we've built a full end-to-end marketing automation pipeline in under 10 minutes. We handled scraping, AI generation, JSON validation errors, and file I/O. To take this further, you'd want to add rate limiting, maybe a database to track what you've already posted, and perhaps integrate directly with the LinkedIn API to auto-post. But as a starting point, this is solid. That's the power of combining modern AI tools with solid software engineering principles. If you want the source code, check the repo in the description. Thanks for watching.